18, true?
Oh my gosh, what?
All right.
Not ready.
Guys, what was homework on before we go there? I mean, we're there.
Limits.
Good, it was on limits.
Graphically and numerically.
Oh, that's area. That's not the right one. There we go. Okay, so number 18. Wait, that's not the right number 18, is it? No. That's the right number 18. The limit as x approaches 0 of secant is 1.
Yeah.
What's number next one?
22.
22.
Oh boy.
Did you guys figure it out as to why?
Oh, was I supposed to say what?
Well, remember the answer key gives what. If you don't know why, then that's kind of defeating the purpose a little bit. What's number next one?
23.
Oh, it's right below it. You guys already checking it? The reason for number 22 is that the one-sided limits do not agree. True? What's the reason for number 24? DNE, because the one-sided limits, once again, do not agree. Good. Okay. Number next one? 26 has a lot of stuff going on. Let me freeze the screen. You guys had a lot of different limits. Was it one of those like big old graphs you had to analyze?
Yes.
Okay, let me give you a second. Letter A was DNE because it wasn't a limit. It was the function. The function does not exist on letter A. Letter B, DNE. Letter C, the function exists. Letter D, DNE. Letter E, DNE. Letter F, 1/2. Letter G exists and it's 2. And H, is it totally showing? Yeah. DNE. However, are there any of the DNEs that the book put technically as DNE, which should technically be, well, not technically, which we could express as an answer and thus we should have? Just H? Because they say it does not approach a specific number, so technically it does not exist, but we said we will state, and for any test, any quiz, any AP exam, we will state an answer if they agree. And so what was the agreed upon direction? Positive infinity. I'm going to go ahead and change that in the answer key over here really quickly. This is one I can save. Good. Thank you for catching that. Thank you for catching that. All right, what's number? Oh no! Why isn't it in there? Oh, that's lame. It's okay, I'll do this instead. And that way I know to talk about it next year. Okay, what's the next even? Do we have any more?
Yeah, 30. Ah, shoot. 30. Yes, that's an even number. Oh, that makes sense why it's so difficult.
Alright, you can see that pretty much, right? Okay. Number 36.
36 is like what? And obviously we didn't have to do it, but and those weird like.
Was it an extra credit one?
No.
Oh wait, did I skip one? Did we do 30?
No. I think Nathan just did it.
Oh, there we go. Oh, Nathan, it wasn't required for homework?
Yeah, I just.
Oh, okay. So number 36 was the last one?
No, 30 was
We did 36
36
was not a
wasn't
problem.
on.
Oh dear. Okay. So 30 I'm supposed to be on. You guys are killing me. You did not have to make this exact graph. This is one graph that fits the conditions that they gave you.
It looks nice.
Oh wait, where'd he go? Go back up. You're supposed to be around him. There we go. Okay. What were the conditions that they told you? Let's quickly talk about why this one works.
Function of 2 is equal to 0. The limit as x approaches 2 is also equal to 0. Function of positive 2
So f of negative 2 is 0?
Yeah.
Why is that true?
Yes, it is.
Because it's like,
It's a closed point at negative 2, 0. Does that make sense? Okay, the next condition was the limit as
x approaches -2. Is 0 as well.
and what did that mean? The function as it came in from both directions had to be approaching what?
Yeah.
The point. Good. Okay, what else did they give us?
Function at 2
Uh-huh.
is 0 as well.
You guys see the closed circle at 2, 0, right? Okay, and then?
But the limit as x approaches 2 does not exist.
Oh, that's all they gave you?
Yeah.
Oh, wow, there
That
was
pretty
tons of
easy.
stuff you could have done then.
Yeah.
Tons and tons. They just gave us one example.
Second.
Oh, man. Tons and tons. Does someone have another example they'd be willing to come up and write on the smartboard? Yeah, as you have your question, Sean, go show yours.
Open circle means that it doesn't approach
It's okay,
I'm the worst
Open
student.
circle.
I'm the worst student.
There
This
can
book is
still
gonna
be
get-
there can still be an approach. The function
This
value
book is
does not
gonna get
exist there.
ruined anyway.
Yeah, the function value does not exist there. But so like f of
Do you know that one example we had? It was an open
Alright,
and a closed
alright,
circle,
good
and
stuff, Sean.
some people got tricked.
right, the approach still exists. You can still be approaching the open circle.
So
Sean, you're up.
It's all about the function. So like the limit as x approaches 2 from below, 2 below negative, is 2, is where the open circle is. Because this part of the graph is headed that direction. This little car is going to this old location in the diner. Does that make sense? So the approach exists.
It does look good.
From above, the approach is 0, and the function is at 0. So the function is 0 because that's where the closed circle is. The function is not there. AKA the diner is really here, the diner is not there. The diner is open for business here, not there. But the limit does not exist, although the approach did exist from each side, but since they didn't agree, then the limit does not exist. Does that kind of make sense? If it was something like this, and this was not there, this would not be true because the limit would exist and the limit would be 2. The function would be 0, but the limit where the function is approaching whenever it's not at 2 is this height, not 0. Does that make sense? Yeah, good question. Did Sean's work, yes or no?
Yeah.
Why? Oh wait, this was below and that was above. Does that make a difference?
Because it fulfills all the parameters.
It's still, each side of the function still approaches this height as it comes in, assuming that hits. Don't worry, I did the same thing. So assuming they both are hitting, they are both approaching the height of 0, so that's perfect. Didn't have to both be above like that funky one. It does come up and it does hit at 0, but from the other side Sean had a hole, and that's totally fine. Do you guys kind of get the idea of what they were asking you to do? Was there some creativity involved? But were there parameters that you had to still fulfill? Yes. Alright, so we had no other evens?
68.
Oh, 68. Number 36, Nathan, that's where I was telling you guys that there's that epsilon delta definition that a college professor would probably show you. So those of you that want to dive in deeper to not just the what can we do with calculus, but the theory behind it, you can look in the section, and that number 36 in those problems, anything where there's a delta, anything where there's an epsilon, I guess epsilon you're pretty much doing yourself. But you're showing basically why the limit is what it is from the epsilon delta definition, and that's the formal definition. Some of you remember that we wrote down the informal definition in our notes. The epsilon delta is the formal definition. Does that make sense, kind of? So, if you want to look at it, it's there. And if you want to dig deeper, it's there, and it would be helpful in the college calculus class. Okay, but number 68 is the last one that we're going to go to. I think it's the last one, maybe it's not. But it's the next even. Oops, I hit something I wasn't supposed to. Number 68, the final answer is false. And they give a counterexample as to why it's not true.
It's a true.
Did they give you a piecewise function? Or did they give you a statement? But it should be written there, just write the question.
True or false with an explanation.
Ah, true, false with an explanation. And Sean, what was the statement?
Dang, I did it for the first one. Second one. You're supposed to write it, Sean.
Sarah, do you have a statement?
No.
Sarah, do you have a statement? Please say the statement. Guys.
You know, I did the whole how I forget.
I get it.
I did
Charlotte has it. Alright, hold on, listen to Charlotte.
If limit x to c, fx equal then fc equal
Okay, so if the limit equals a number, then the function equals a number. Those of you guys that don't have it written, guess what? I'm gonna look at number 68 when I grade your homework spiral.
Don't
On the
writing
daily test.
Misty, I'm
You
writing
better make
right
sure you
now.
have the question somewhat summarized. And I just told you,
Wait.
ready? If the limit as x approaches c of f of x is L, then f of c is L.
Oh my god, there was there.
Oh wait, it was there the whole time? Oh, this is so sad, Sean.
It was there on my paper too.
Wait, you're angry or angry?
It's
Both.
angry.
You did not have your breakfast this
I'm a
morning?
little tame.
I have a Cliff Bar. It's a little tired.
Alright, then how does this statement, question, you could have even done a graph, you didn't actually have to write out a function. But what scenario is going on in this piecewise function, kiddos? Do you know how to graph x minus 4?
Yeah.
Hopefully, mx plus b, right? 1, 2, 3, 4, negative 4. Got it? Going up 1 over 1, but it's everywhere but what? Uh-huh. I'm going up 1 over 1, up 1 over 1. Ooh. So that's x equals 2, so I'm going to do a whole. Okay,
Oh, boy.
That's a quality graph.
that was party.
That was
Oh, that's exciting.
Party waiting to happen right there. Okay. Okay. What is going on does the limit exist?
Yeah.
Does the limit equal an actual number, and what would that number be? Negative 2, right? The limit exists, and the limit is negative 2. What is the dilemma with, okay, so the limit as x approaches c of f of x is L, then f of c must be L. What's going on in this piecewise function?
Well, it's telling you at 0.
It's not.
It's saying fill the dot at 0. It's one of those examples like Austin brought up a second ago about, hey, it's not there, it's there. Does the limit exist? Yes. What is it? Negative 2. Does the function exist? Yes. But what is it? So do the two have to be the same? Just because the limit exists does not mean that the function is there. There are these things that we call discontinuities, and they usually occur in piecewise functions. That's why we're going to learn to watch out for those piecewise. Any more evens going once? Any more evens going twice? Sold. Any questions on odds? You guys okay?
Wait. I might actually. No, I don't.
Okay, we're good? Alright. Question. Are we using CalcAB wisely? If we're using it at all.
It's too hard to figure out.
Okay.
Wait,
I could've
But my question is, well, here's start here. Did anybody go to CalcAB even once? And I totally am not judging because it's a good thing if you did, if you were stuck. Did anybody go to CalcAB at least once?
Yeah, but I just did
Okay.
it on my own.
That's sometimes the case. Okay, so you went to CalcAB at least once. How many of you guys think that you at least were able to fix your mistake or make the jump that you were stuck at after going to CalcAB? Okay, that's using CalcAB wisely. That's saying, I was stuck, I went, and I think I figured it out. And I think I was able to keep doing homework as a result of figuring that one out. Does that make sense? That's a helpful way of using CalcAB. Now, if you go to CalcAB and you're like, it's just confusing, they jump, they skip steps. And if you guys are ever confused by a CalcAB solution, ask me that too. Because remember I say, that's them solving it, not me solving it, and I'm the one getting you to the AP. True?
Roast.
So, no, I'm not roasting, just they're grad students and they make jumps, especially when it goes to simplifying derivatives. They're going to make huge jumps. You're like, how did they get there? So ask me that. Be like, I don't get this. Sure, I saw their solution, but I don't know how to connect the dots. I don't know how to finish the puzzle. Does that make sense?
Yeah.
Cool.
Is there an online book?
Kind of.
Kind of.
There's this thing called WebAssign, and I need to set up a class and get you guys like usernames and passwords. The problem is that computer is dying on me, and Mrs. Christensen this week is trying to get me a new computer so that I can have the web assigned for you guys to see both up here and then get it. Now I can work on it on that one, but I have to get grades updated first, which I got a lot of grading done. You guys are getting a lot back tomorrow, including the quizzes. Good thing the summer packet was a test grade, unless your summer packet wasn't 100%. Then
I have two questions. One, do you post homework in the Google Classroom or just on Google?
just on my calendar.
So when are we gonna have Google Classroom set up?
Google Classroom. See, I'm kind of figuring whether I want to do just WebAssign or WebAssign and Google Classroom or just Google Classroom. I want to get you guys WebAssign just so you can get the online book, but there's also online assignments. That's awesome. Our department stuff, probably not me, Okay, so you guys don't have any questions on CalcChat solutions, on odds in general, or on evens. Cool. Homework put away? For those of you guys that didn't have it done today, what are you going to need to do?
Finish it.
You're going to need to finish it and do what?
Correct it.
Grade it. Do not fall behind in calculus. You have technically a kind of a free night, but what's your homework supposed to be tonight? Start. Alright, cool kids, here we go.
Let's do this.
Tomorrow, we are going to start in our workspace. Tomorrow, we're going to start in our workspace with some multiple choice practice. Ooh, that'll be fun. But that's tomorrow. We're going to start in our workspace in the back of our spirals. So make sure you bring your spirals every day as well as your composition books. Not only for reading, but also for openers. So be ready tomorrow. Right after HCTV, you guys are going to have what's seen as, or could be seen as, a pop quiz. I'm just not correcting it.
Do we need to bring a book to class?
No, because I have. And if there was something where you needed it, some people do bring it to class because they like having it, but I also have 1, 2, 3, 4, 5, 6 spare books, and there are 1, 2, 3, 4, 5 groups. Okay. You guys will like this section because these are the limits that are fun.
Yeah.
This is where 0 over 0 keep going comes in.
Yes, I think I lost my calculus. I don't know.
Did you leave? You want to check your locker?
No.
Are you sure? And it's not in the front. You were being amazing and using it on homework?
Oh wait. Oh, never mind.
Oh.
I think it's not. I think it's not taking little hype.
Alright. The first box at the very beginning, it says some basic limits. Why does it make sense that the limit as x approaches c of a constant b is still b? An example of which is letter A. How can you apply number 1? Let me give you 2 more seconds, sorry. Hold on, get the box down first. But then as you're writing the box, look at the examples below, or maybe right after you finish writing the box. I want you to figure out which goes with which. Hint, A goes with 1, B goes with 2, C goes with 3. Shouldn't make it super confusing. I want you to look and see why it makes sense. Yeah, don't think about it. What this? You gotta like raise it up, but depends on the way you not, yeah, I know. Thanks, Seth.
Sarah's a disruption to the class, okay?
Okay.
I get mine here.
So we just get to see you at
She's
your
better by
own
third
level.
period. She's better by third period.
And then where's
This is my little
Interesting.
Do you have a high point?
Makes sense.
Okay, how'd you guys apply to letter A?
Oh, what?
What would you have done before, or even with the box, or even before the box? How do you take the limit as x approaches 2 of 3? Really? Not easy.
Three?
Limit as x approaches any constant of a constant is always going to be the same constant?
Because it's a point, right? I don't understand.
Well, pause. What does y equals 3, the function, look like?
2, 3. Probably.
Wow.
So then, as x approaches 2, where are you approaching? 3. How about as x approaches 3? 3. How about as x approaches negative 2? Yeah.
Misty, you're going too fast.
3 is 3 is 3 is 3 is 3. Remember, a limit is the height, and what's the height of y equals 3? No matter what. Now, here's another way of looking at it. How would you guys think about letter B? Then we'll go back to letter A and talk about another way algebraically y is 3. How would you do letter B?
It's negative 4 times y.
Yeah, you can look at number 2 up here. The limit as x approaches c of x is c. But what did we talk about last year, those of you that remember, about how to solve easy limits? Or how to always try to plug it in. To what?
Oh.
The variable. So plug in negative 4. Oh, it's negative 4. Now if you want to think about a graph, because we were doing graphs last section. My voice is scratchy. I don't know why. As x approaches negative 4. Remember, y equals x, which is the function. Yeah, it would make sense, right? Because remember, I have 0, 0, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4, right? So as I have my y equals x, as x goes to negative 4, it's approaching the y value of negative 4. That makes sense on the graph. But remember, we can just plug it in, plug it in. So let's go back to letter A for just a second. Okay, if we can just plug it in, plug it in. Oh, hi, who are you? Oh, I had answers hidden. That's cool. Anyway, is there a place to plug 2 into? There's no x. So you plug in 2 and you're like, oh, well, there's no place to plug it in. The answer's 3. Right? Does that make sense? So if you were down here and if it was x plus 1, wouldn't you have just plugged in negative 4 to x and then added the 1? The constant stays the same. It is what it is. So then why is the answer, the letter C, 4? Because you plug in 2, 2 squared is 4. And that's what it says up here. The limit as x approaches c of x to the n equals c to the n. So the long story short of this little table, it's a snazzy table. I think probably the most confusing one for you guys to focus on is just number 1. It is easy to confuse something like letter A. And so you kind of get it down. But if you remember, last year I said you can always plug it in for well-behaved functions. What's something that's not well-behaved? A piecewise, we have no idea what's going on there, right? Who knows if they connect, who knows if they disconnect, who knows what. Piecewise are not well-behaved. What else? Yeah. The nasty oscillating. Now, hold on. How could you see that in the equation, though?
Like
Let's
x
assume we
in
don't
the
have the graph.
denominator?
X in the denominator, or some x function expression in the denominator. Where else could something be that would cause problems? Think some of that. Yeah, so in the denominator, if an x expression is in the denominator, whether 0 over 0 or number over 0 when you plug in. How about square roots? How about logs? How about trig? Right? If we have asymptotes and stuff like that going on. Okay, let's keep going. Oops, that didn't work. Let's try the arrow.
Well, that's gonna be fun, right?
Geometry flashbacks.
Okay, properties of limits. I actually want you guys to write them down.
Do we have to write theme?
Because it does allow you to split up, break apart, do limits a little bit more piece by piece instead of being super overwhelmed by functions. So all the way through, B and C are just real numbers. Could be positive, could be negative, doesn't matter. N is a positive integer. As far as, I think N is only used in powers. So they're saying positive powers, not negative powers. And we know limits. We don't have a graph. We don't even necessarily have a function. We might. I guess we might have a graph as well. Sometimes the AP likes to randomly confuse. But long story short, we know something, but probably not everything, about the limit as x approaches c of f and the limit as x approaches c of g. capital L is just a constant, capital K is just a constant. Basically forms the foundation for if or when what you guys write. We have an example down below. I'm going to show another example up on the board.
Chapel today?
Technically last year we went into limits really, really quickly. And so I showed you some tricks really, really fast. But technically, limits take a while to build, meaning all we can assume at first are just the three that you wrote down originally. Limit as x approaches c of b is c, limit as x approaches c of x is c, limit as x approaches c of x to the n is c to the n. Okay. We have to start there. But then these properties are what allows us to more generally, more broadly apply. And whenever you see a new box or a new set of properties in math, it means that there were new probably constructs that had to be proven in order to state the validity of these properties. When this math was new math, they couldn't just make jumps and be like, oh yeah, I think it's true, because they wouldn't really know how to check it. They had to prove, and that's why pure mathematicians, well, they just think differently. It's all the behind the scenes stuff. So these properties had to be proven separately. They were, so we can use them. It allows us not to have to look at the graph or know what the graph looks like. It allows us to work piece by piece through a limit. Now, derivatives are a bit more complicated. They come from limits, but they do not have a set of properties just like these. Some of them are the same. Most of them are different. The derivatives 1 and 2 will mostly be true if you were to replace the limit with d dx. 1 would be true. Number 2 as well if you were to replace the limit with d dx. 2 would be true, but 3 and 4 and 5 are not. They're not always true throughout calculus, but they are always true for limits. So kiddos, how many of you guys right off the top of your head know exactly what this graph looks like? But without going to a graph, without going to a table, we can look up here and say, hey, if we have a sum, we know it's a parabola, and we know that it's concave up, and we could find probably the zeros very quickly. We have x equals -1 and -4, right? You could figure out the vertex is probably halfway in between. We could figure out stuff. But without having a graph, without having a table, we can actually look up and say, hey, what do we do whenever we have addition and subtraction of multiple pieces, like an x to an n and an ax and a b? We can just, we don't need to factor. We can just take it piece by piece and say, well, just take the limit of that guy, and just take the limit of that guy, and just take the limit of whatever's being added or subtracted. And how do I take the limit? Plug it in. So take the limit of x squared, and what do you do? Yeah. Take the limit of 5x. Take the limit of 4. Just 4. And our final answer is 4 plus 10 plus 4 is 18, right? These properties allow us to take it piece by piece and not have to think about it as one whole function, but think about it as addition or subtraction of separate pieces. Same thing with property number, 3? Property number 3 allows us to approach a problem like this. We don't have to know what e to the x times 1 minus sine of x looks like. We don't have to know all these different values when x is negative 10 and negative 5 and negative 1.01. We can just say, hey, according to that, right? Take the limit of f times take the limit of g, L times k. So what's the limit of e to the x as x approaches 0? What are you going to do? Plug it in, so we're going to have e to the 0. Times, what's the limit as x approaches 0 of 1 minus sine of x? Plug it in. Now, you guys notice, this takes calculus to even know how to plug it in. But this takes algebra 2 trig just to finish the problem, right? So, what is sine of 0?
0.
Ah, 0. Careful, what's e to the 0?
1.
What's 1 times 1? 1. But do you guys see what I mean by we need unit circle? Because it'll help us finish answers. Struggle. Let's keep going. I think we have enough for maybe one more slide. Nice thing is, tomorrow, once we get past the foundation, we just get to play around with. Ooh. What's this whole page saying?
Plug it in.
Plug it in. Try direct substitution first. In any limit problem, well, you'll learn, I guess there's one type that maybe that's not the first thing to try. But it still is okay to try that problem too. Always try to plug in. Plug into who? Do you guys see what I'm giving you? You don't even have to write this stuff down if you can figure out what I'm telling you. I want you to at least write these down. Just a moment ago, I said always, always, always plug in, and it will work for what kinds of functions?
Those ones.
Well-behaved. Who are the well-behaved? These ones. But there are a couple exceptions. One of them is rational. It's going to be great unless it's going to be great as long as the denominator is not 0. Same with radical. It's going to be great if I have an even-powered root. It's going to be great as long as c is positive. It's up to you. You can word this different ways. You don't have to do all the equations. Composite functions is going to be great as long as, well, there's no discontinuities or undefined points.
What do you mean by many times?
I mean like the majority of the time. Many times is going to work. And then I give you examples as to when it's going to work. So a lot of the times the limit as x approaches c of f of x is as simple as plug it in, f of c. Does that make sense? So that's true many times. And these are examples of when it will work. But my exceptions are when it won't work. The denominator is 0, we're in trouble. If we have a negative under square root, we're in trouble. If c equals, I'll put this, 4, not equal to, for tangent, it can't equal negative pi over 2 or pi over 2 or anything moving pi away. Because it would be at a vertical asymptote, right? Down below it says exponentials are good. Logarithmics are good. Basically anywhere in its domain. So the long story short is plug it in. If it's not in the domain, if something is undefined, well, we got to do another way. And so tomorrow, if you guys can imagine, we're going to look at maybe some of the easy ones, but then we're going to look at the tricky ones. We're going to say, okay, let's review. What happens if you have 0 over 0? How do you keep going? But are these things that you saw in your summer packet? And the answer is yes. Could you go back to calculus-help.com and watch the limit videos again? Yeah, you could, if that would be helpful. Not a bad idea. Or you go to CalcAB and watch limit videos if you want to just have a one-up. Or you're catching up on the graphical numerical in section 2 because you don't want to be behind in calculus any longer. Now cool kids, if you can imagine, if this is basically summer packet, couldn't some of you start homework number 3 tonight? You're just plugging in. And if it doesn't work, 0 over 0, keep going. And if you get there and you don't know what to do, wait until tomorrow. Sound good? Alright, cool kids. It's time. The imaginary bell has rung. See you guys later.
Sarah, you need to take it down a couple notches, okay? I'm just trying to go to golf here, okay? And I can't do it with you.
Guys, hang in there. Hang in there. You did fine. How was your weekend?
It was very good.